Have you ever caught your reflection in the back of a shiny spoon and just wondered why you look so weird? Or maybe you've been to a carnival and seen those crazy funhouse mirrors. Well, guess what? It's not magic, it's physics. And today, we're going to unlock the secrets behind every single one of those curved reflections. So let's dive in.
So here's the plan. First, we'll tackle that whole funny reflection in a spoon. Then, we'll dig into the actual science of curves. From there, we'll see how mirrors mess with light, make the leap over to lenses, and finally, we'll discover how all this amazing science is hiding in plain sight all around you every single day.
All right, part 1, funhouse mirrors and spoons. Let's kick things off with the puzzle you've probably already stumbled upon in your own kitchen.
I mean, come on, who hasn't done this, right? You pick up a really clean, shiny spoon and bam, there's your face staring right back at you. But something's not quite right.
And that's the million-dollar question, isn't it? When you look into the bowl of the spoon, your entire world is flipped on its head. How in the world is that even possible? You know, it's such a classic experience. There's this story about a student named Mina who goes to a science center and gets totally confused by these curved mirrors. She sees her face get huge, and then she sees her brother get flipped completely upside down. The thing is, this isn't some weird fluke. It's all happening by design.
So what's really going on here? Well, that brings us right to section 2, the science of curves. The secret to all these wacky reflections isn't the metal of the spoon, it's all about the shape.
First up, we've got something called a concave mirror. Now, the easiest way to remember this is that the surface literally caves in, just like the name. This is the side of the spoon you scoop your cereal with, and its unique shape is the magic behind everything from super bright flashlights to giant space telescopes.
And the total opposite of that? That's a convex mirror. This is where the shiny surface bulges out towards you.
Just flip that spoon over, and you're looking at one. This shape is all about seeing the big picture, which, as you'll see, is a huge deal for staying safe on the road. So here's the deal in a nutshell. The concave side, the inside of the spoon, that's the one that can flip your image totally upside down. But the convex side, the back of the spoon, it'll always show you right side up, just a little smaller. You can try this right now. Seriously, go grab a spoon. Look into the inner concave side really close to your face. Now, slowly pull it away and just watch what happens. Your reflection flips. Then, turn the spoon over to the convex side. No matter how far away you move it, you stay upright. You just get smaller. Pretty neat, huh?
Okay, so we know the shapes, but how do those shapes actually create these images? That brings us to our next section. It all comes down to bending beams of light.
See? On a normal flat mirror, light bounces off in a really simple, predictable way. Angle in, angle out. But the moment you add a curve to that surface, oh man, you change the angle for every single beam of light hitting it. And that changes the whole game.
And this is where it gets really interesting. The two mirror shapes have completely opposite jobs. A concave mirror is like a funnel for light. It gathers up all the light rays and brings them all together, focusing them on a single point. We call that converging. A convex mirror does the exact opposite. It takes light rays and spreads them out, making them diverge, kind of like water from a sprinkler. This one simple difference is the key to everything.
So, we've seen what happens when light bounces off a curved surface. But now for a twist. What happens if the light could pass right through it? Well, that brings us into the awesome world of lenses. Yeah, this is the fundamental shift. Instead of getting a reflection, we get a view. We're not looking at a lens, we're looking through it. But you know what? The same rules about curves still apply.
And check this out. It's a perfect parallel to what we just learned. A convex lens, which is thicker in the middle, does the same job as a concave mirror. It converges light. And a concave lens, which is thinner in the middle, does the same thing as a convex mirror. It diverges light. It's the same physics, just in a different package.
So what does this actually mean for what you see? Well, a convex lens, that's your classic magnifying glass. It can make things look way bigger. But just like its mirror cousin, if you mess with the distance, it can also flip the image upside down. A concave lens, on the other hand, will always show you an image that's upright, just a bit smaller.
And this is the payoff. This brings us to our final section, where we connect all the dots. Because this isn't just theory in a textbook. This is the tech that literally shapes the world we see. This is mirrors and lenses everywhere.
Okay, quick recap.
Concave mirrors. They do two things really well. They focus light to a single point, or they magnify stuff that's super close. So where might that be useful? How about in your car's headlights? They use a concave reflector to take the light from a tiny little bulb and shoot it out as a powerful focused beam. Same deal with a flashlight. A dentist uses a tiny concave mirror to get a magnified up-close look at your teeth. And the biggest telescopes on Earth use massive concave mirrors to gather faint light from distant galaxies.
All right, now for the other team. Convex mirrors. Their superpower is spreading light out, which gives them a gigantic field of view, even if it makes things look a bit smaller.
And that leads us to this. You have seen this warning on your car's side view mirror 1,000 times. Well, that mirror is convex. It's giving you a really wide view of all the traffic behind you, but it pays a price. It makes those cars look smaller and farther away than they actually are. And now you know exactly why.
And finally, lenses. Oh man, lenses are absolutely everywhere. They're in the eyeglasses that help millions of people see clearly. They are stacked inside the camera on your smartphone. They let scientists peer into the microscopic world and, most amazing of all, you have a powerful, self-adjusting convex lens built right into your own eye.
That's right, the same science that powers giant telescopes and smartphone cameras is working inside your head this very second, letting you see the world. It's not just in a science lab, it's a part of you. So the only question left is, what amazing things are you going to focus on with it today?